Welcome to The Explainer. Today, we're diving into what is basically your ultimate roadmap for mastering the Cambridge International AS and A-Level Physics syllabus. We're talking course code 9702. Now look, it's a rigorous journey, no doubt about it. The stakes are pretty high, but with the exact right strategy, it is incredibly rewarding. So, let's unpack the blueprint that's going to guide you straight to success. So, here's the million-dollar question, right? How on earth do you master the fundamental laws of the entire universe while simultaneously preparing for a seriously demanding, highly structured exam? I mean, it can feel like a monumental challenge. You aren't just memorizing a list of random facts here. You're literally learning how to think, analyze, and solve complex problems exactly like a true physicist. But hey, good news. You've got a comprehensive toolkit right at your fingertips. Today, we're going to look at exactly how to use the structure of your course materials so you don't just survive this syllabus, you absolutely conquer it.
Real quick, here's our game plan for today. First up, we're navigating the syllabus structure itself. Then we'll dive into the core physics concepts, kind of the philosophical foundation of the whole thing. Third, we'll check out the essential learning tools built right into your materials. After that, we break down the actual assessment papers. And finally, we'll decode the examiner command words, which, honestly, is the absolute highest stakes part of your exam strategy. Let's get into it.
All right, Section 1, Navigating the Syllabus Structure, because knowing the terrain is rule number 1.
Okay, so your course has a very clear two-tiered structure. If you're focusing just on the AS level right now, your territory covers topics 1 through 11, and that's going to prep you for papers 1, 2, and 3. Simple enough, but if you're stepping up to the full Cambridge International A-level course, your journey extends through topics 12 all the way to 25. And that extra chunk of content, that is exactly what you need to master for papers 4 and 5. It's a nice, clean split which really helps you compartmentalize your study goals. But wait, then we have the magic number 26. Topic 26 is kind of its own beast. It's a completely standalone chapter dedicated entirely to practical work. Because remember, physics isn't just a bunch of theories on a chalkboard, it is a deeply experimental science. This standalone topic is absolutely crucial because your practical skills are tested heavily, regardless of which tier you're doing. You're definitely going to want to return to this topic over and over again throughout your studies.
Moving on to Section 2, Core Physics Concepts. Let's look at the big ideas that tie the whole universe together. The first big concept here is the use of models. Physicists are constantly, and I mean constantly, developing models of physical systems. Why do we do this? Well, the universe is incredibly, overwhelmingly complex. Models simplify all that chaos. They help us explain what we're actually observing, and, this is the key part, they let us predict how physical systems are going to behave under totally different conditions. So, whenever you're learning a new formula or some new theory, just remember, you are essentially learning a model of reality. But here's the catch. Models are completely useless if we don't test them. And that brings us to our next core concept, testing predictions against evidence. See, physical models usually come from prior observations, sure, but they have to be rigorously tested to make sure they actually hold up in the real world. This is the absolute heart of the scientific method, right? Obtaining hard evidence, usually by running experiments, to validate or tweak our theories.
Next up, we've got the fundamental building blocks of, well, everything. Matter, energy, and waves. Literally everything in the universe is made up of matter, energy, or both. And this perfectly illustrates just how interconnected physics really is, because waves act as the primary mechanism for transferring that energy from one place to another. From the visible light hitting your eyes right now to the Wi-Fi in your room, understanding waves is an absolute must.
Finally, we need to talk about forces and fields. How do matter and energy actually interact with each other? Through these fundamental forces that basically govern the entire universe. And what's super fascinating here is the sheer scale of these interactions. I mean, your syllabus is going to take you from the unbelievably tiny distances of quantum and particle physics all the way up to the massive, mind-boggling scales of astronomy and cosmology. Forces and fields are the invisible hands shaping the whole shebang.
All right, Section 3, Essential Learning Tools. Let's look at how your textbook is actually designed to help you out day to day.
So your study material isn't just a giant wall of text. It's built with a very specific sequence to optimize how you learn. Step 1 gives you starting points. These are key bits of foundational knowledge, like giving you a quick refresher on the scientific method before throwing you into the deep end. Then Step 2 is all about worked examples. This is huge. It's where you see problem solving in real-time action, like exactly how to convert milligrams to micrograms step by step.
And then step 3 features end-of-topic questions, which actually include real past exam questions, so you can immediately put your understanding to the ultimate test.
Now, a super crucial tip is knowing exactly where to look for your most important takeaways. Throughout your book, all the key points and definitions are highlighted in these blue panels. For example, you'll see Newton's first law neatly boxed up in blue. Every object continues in its state of rest or with uniform velocity unless acted on by a resultant force. When you are cramming or, revising, these blue panels are literally your best friends for a quick, high-yield review.
You're also going to bump into 2 other really special features, maths notes and extension boxes. Look, physics is fundamentally math-heavy, right? So the maths notes step in to guide you through the tricky quantitative stuff, like navigating the 2 different solutions for the defining equation of simple harmonic motion. Extension boxes, on the other hand, give you this really fascinating context that goes totally beyond the syllabus. For instance, explaining how redshift and blue shift are used in astronomy to figure out if a star is moving toward us or speeding away. It's a really cool bonus, especially if you're planning to take physics to the university level.
Moving on to Section 4, the assessment papers. This is the main event.
Okay, if you're on the AS level track, you are going to face 3 distinct papers. Paper 1 is your multiple choice exam, clocking in at 1 hour and 15 minutes. Paper 2 tests your ability to tackle structured questions, also 1 hour and 15 minutes. And then paper 3. Remember that standalone topic 26 we talked about earlier? This is where it comes into play. Paper 3 is a 2-hour hands-on examination of your advanced practical skills. So, 3 papers, 3 completely different formats to master.
Now, if you're going for the full A level, you take those first 3 papers plus 2 extra highly rigorous assessments. Paper 4 dives super deep into A-level structured questions for a full 2 hours. And then paper 5, which is 1 hour and 15 minutes, tests planning, analysis, and evaluation. This paper is no joke. It really pushes you to think like a fully independent scientist, analyzing raw data and actually designing experiments from scratch.
Which brings us to our final part, Section 5. Decoding command words. Time to learn how to play the examiner's game.
Listen closely because in Cambridge exams, words like calculate, determine, and suggest are not interchangeable. If an exam tells you to calculate, you've got to mathematically work out that exact answer from the given facts or figures. But if it says determine, you need to establish the answer using the available info, which might actually mean reading a graph instead of doing pure math. And if it says suggest, that means the examiner actually wants you to apply your knowledge to a totally new situation where there could be a few valid proposals. You absolutely have to play the game by their rules to win those marks.
Here is a trap I see students fall into all the time, confusing explain with state. If a question just asks you to state a physical law, all you do is express it in clear, precise terms. Boom, short, direct answer. But if it asks you to explain, you've got to lay out the purposes, the reasons, the relationships, and provide actual evidence for why or how something happens. If you write a massive, sprawling paragraph when you were only asked to state something, you're just bleeding precious time. And if you drop a one-word answer when asked to explain, it is going to cost you heavily. Don't leave those marks on the table.
So, what does this all mean? The biggest takeaway here is that mastering this syllabus, and especially decoding those tricky command words, isn't just about hacking a test. It's about learning how to communicate precisely and effectively, exactly like a professional physicist does. This isn't just exam prep, it is literally your first true step into rigorous scientific inquiry.
Which brings us to the end of today's explainer. I'm going to leave you with one final question. Are you ready? Because you have the map now. You know the core concepts, you know the learning tools at your disposal, you understand the structure of the exam papers, and you've cracked the secret language of the examiner's command words. It is time to begin observing, measuring, and absolutely mastering the Cambridge 9702 physics course. Good luck on your journey, and I will catch you in the next explainer.